السلام عليكم. My name is Fahad Isa and I'm in chemistry class, chemistry class level 3. And my topic is about how to calculate molar mass of compounds. Learning how to calculate molar mass helps you if you were to determine the empirical formula, molecular formula, and percentage composition. Let's start out with defining molar mass. Well, molar mass is the mass in grams of 1 mole of a substance. If you find out the molar mass of a specific element, you have to include the molar mass unit. Let's show you how to show it. If you already find the molar mass of the element, you have to include the units of the set. So grams. This includes grams per mole. Okay, now let's figure out. I'll teach you how to find the molar mass of a specific element. Let's choose any element from group 1 to 18. Let's choose iron, which is Fe. First, let's start with Fe. Then the molar mass of iron is 55.845. I said earlier you have to include the units, which is grams per mole. So I basically just look for the molar mass of iron and include the units. Now let's show you how to calculate molar mass of a diatomic molecule. Now the following equation is bromine. Okay, this subscript indicates the mass of the mole in bromine. So the first step in this question, you have to find the molar mass of bromine, which is 79.904. Okay, then what you do, the second step is you multiply by the mass of the moles, which is 2. And also it's called a subscript. Then you find the answer, which is with total of 159.808 grams per mole. Okay, so what I did here is I found the molar mass of bromine and multiplied by the subscript of the mass of the mole, and it gives you the molar mass of this atomic molecule. Okay, now let's show you how to calculate the molar mass of a compound. So the following question is C12, H22, and O11. First, you have to find work by lining them up. So carbon and hydrogen and oxygen. First step, you have to find the molar mass of each element. So carbon, the molar mass of carbon is 12, hydrogen is 1, and oxygen is 16. Then you have to multiply by subscript of each element, or the mass of the mole of each element. So carbon is 12, hydrogen is 22, and oxygen is 11. Now multiply 12 times 12, which is 144, and 22 times 1, which gives you 22, and 16 times 11, which is 176. So now, third step, you have to add them all by itself up. So 144 plus 22 plus 176, which gives you 342 grams per mole. And this is the total mass, which is 342 grams per mole of this compound. So what I did here is I found each molar mass of this element. Then I multiply by each of the subscripts. Then I add them by all up, which gives you the total of the molar mass of this compound. Now let's show calculating molar mass. The following question requires again one more step than this question. One question is manganese 3 and PO4 2. Okay. Now don't get frightened by the brackets. If you see a bracket, you have to have the subscripts outside. Okay. So now you multiply this mass of the mole by the compound inside the bracket. So let's simplify, which gives you Mg3, so P2O8. Okay, this is the extra step than the earlier question. Okay, now you have to line them up or plan your work. So manganese, phosphorus, and oxygen. Find the molar mass of each element. Manganese, manganese is 24. Phosphorus, which is 31, and oxygen, which is 16. So now what we're gonna do is we have to multiply by each of the subscripts. So 24 times 3 manganese, and phosphorus times 2, and oxygen times 16 times 8. Okay, now find the answer. 24 times 3. 24 times 3 is 72, or 72, yes. 31 times 2, which is 62, and 16 times 8, which gives you 128. So it's a total of 262 grams per mole. So the total molar mass of this compound is 262 grams per mole. Okay, so what I did basically is I find that I simplify the bracket, and I find the molar mass and multiply by the subscript. So I guess this is it, and I hope you actually learned something from my lecture, and thank you very much.